Alright, so now we're gonna solve question 7, which is telling us without using a calculator, try to find out these expressions, part A, part B, part C, tangent alpha, sine 2 alpha, and cosine 4 alpha, where the alpha is trapped inside this original equation. 1 plus tangent alpha over 1 minus tangent alpha is equal to 3 plus 2 root 2. And alpha is an acute angle. Huh? Okay, good. So what can we do? Well, what we can do is to realize that 3 plus 2 root 2 is really just a number. It's just that it looks a bit ugly. Don't judge the number. It's just a special looking number with a lot of square roots going on. Of course, if you type it into the calculator where everything is fair and standardized, you will realize that it's just 5.828427125. It's just a long decimal. Just like all the other weird numbers that you type in the calculator. They are just a long decimal, right? So what this means is you can just treat it as a number. It is simply a number. Then what you can do now is, well, if you want to solve for tangent alpha, maybe a good idea is to just flatten out the fraction by multiplying the denominator over. In other words, what I'm saying is denominator, this guy, times over. Just treat this as one number, then distribute into each of the terms. Distribute into 1, distribute into negative tangent alpha. Huh? Maybe, yeah. Okay, and let me just show you what I've done so that it's faster a little bit. So what I did here is I simply multiplied the 3 plus 2 root 2 over. Yeah, this is what I did. I multiplied it over to this guy. Then what I did next is I realized that, hey, 3 plus 2 root 2, you can just treat it as one lump. And then the 1 and the negative tangent alpha, let me just resize this a bit. The 1 here and the negative tangent alpha, there are two terms. So you can just distribute this 3 plus 2 root 2 into the 1, this 3 plus 2 root 2 into the negative tangent alpha. So what happens when you do that? 3 plus 2 root 2 times 1, 3 plus 2 root 2, that's the first term you got here. Then you got 3 plus 2 root 2, 3 plus 2 root 2 3 plus 2 root 2 multiplied by 1 gives you this first term. Let me just erase that now. And 3 plus 2 root 2, if you multiply into this second term, you will get this expression over here. Right? With a negative sign in front, because negative. Okay? Okay, clear? Clear, good. So now we will have this expression. Of course, the left hand side, the numerator of the previous fraction stays the same. So what do you have next? What we have next is that we are going to combine like terms. We want to make tangent alpha the subject, right? That's what part A is asking for, make tangent alpha the subject. So very simple, we just need to identify the like terms. In this case, we have tangent alpha. We have tangent alpha, but it's a imaginary 1 times tangent alpha. But this one is not imaginary, it's a negative 3 plus 2 root 2 times tangent alpha. So very simple, we just bring this over to the left hand side. And then the constant over here, well, it's not related to tangent alpha, so you bring it over to the other side. Okay, and what do you get at the end of the day? You'll get this expression over here. Tangent alpha plus bracket 3 plus 2 root 2 bracket tangent alpha equals to 3 plus 2 root 2, this guy 3 plus 2 root 2, then the 1 bring over, so minus 1. Okay, good. We got this expression. Good. Now we move on. We try to factor out the tangent alpha. You see here, there's a tangent alpha. Here, there's a tangent alpha. But you can factor out tangent alpha, right? Yes, then you'll get, let me just show the working a little bit. This one, what I did is I factored out the tangent of alpha. Then I realized that it has 1 copy for the first term and 3 plus 2 root 2 copies of tangent alpha. 1 lot and 3 plus 2 root 2 lots of tangent alpha. And then it's equal to 3 plus 2 root 2 minus 1. 3 minus 1, you're left with 2. So, okay, I better don't cancel. I think it's a bit messy already. You can see, better don't cancel. So 3 minus 1 is really just a 2. The plus 2 root 2, nothing happens, so just copy and paste. Good. Now, can you make tangent alpha the subject? Of course you can. You got tangent alpha as the subject. Make tangent alpha the subject. But you have this extra factor 1 plus 3 root 2, right? So you just have to bring it over. right? Oh wait, but before that, yeah, yes, this is what I was doing. 1 plus 3 plus 2 root 2 is really just 4 plus 2 root 2, but it's really just 2 times of 2 plus root 2. Huh? So now it becomes 2 times 2 root 2 times tangent alpha, which is what I've written here. Okay, which is why I've written there. But this 3 plus 2 root 2 minus 1, the 3 minus 1 becomes a 2, 2 plus 2 root 2. You can actually factor out a 2 here, so you get 2 bracket 1 plus root 2. But since left hand side and right hand side both have a factor of 2, you can cancel them off, which means that you're left with 2 plus root 2 bracket times tangent alpha is equal to 1 plus root 2. Now you can make tangent, finally, you can make tangent alpha the subject, which is 1 plus root 2 over 2 plus root 2. And then you are done. However, since this is A max and we are testing you on basic concepts, we want you to also rationalize the denominator. Meaning that we have tangent of alpha equals to this fraction, but we want you to rationalize the denominator. Yeah, let's just try and rationalize it. We have 1 plus root 2 over 2 plus root 2. Can we rationalize it? Of course we can. 2 minus root 2 over 2 minus root 2. That's the conjugate, right? Then denominator, what happens? A plus b times a minus b. So a square minus root 2 square. What's root 2 square? It's nothing but 2. What's 2 square? It's nothing but 4. So 4 minus 2 is just 2. Okay? Can I'll just skip the steps. Then in this case, at the numerator, you have 1 plus root 2 times 2 minus root 2. You don't need to copy down again 1 plus root 2 times 2 minus root 2. No need. There's no need. Just draw the brackets around your original numerator neatly like this. My handwriting is not so neat, but still legible, I hope. Let me know if it's not. I will make a clarification. Yeah, so this one, you just need to know that there's a binomial, 1 plus root 2, 1 plus square root 2, multiplied by a 2 minus square root 2. Then very simple, just rainbow method, distribute. 2, 2, then this one, 2, 2, multiply out. So what was I saying? Yes, you should multiply out now. So first term 1 plus times first term 2, what do you get? 1 times 2, 2. First term 1 times negative root 2, what do you get? Negative root 2. First term square root 2 multiplied by 2, what do you get? Plus 2 root 2. Square root 2 term multiplied by negative square root 2. You get negative, but square root times square root gives you a 2 itself. Oh, what do you notice? 2 minus 2 cancel off. Minus 1 copy of root 2 plus 2 copies of root 2. How many copies of root 2 left? 1 copy of root 2. All divided by 2. Then we are done. Or, yeah, because we have a rational denominator, we don't try and simplify further. So that's for part A. How about for part B, sine of 2 alpha? Sine of 2 alpha. Now, okay, it's I've already written it over here. The hint that I have is sine of 2 alpha is really just 2 sine alpha cosine alpha. It's based on your formula, right? Based on your formula list. In this case, take a look at tangent alpha, which we have already found previously. Tangent alpha was found to be square root 2 over 2 from part A. What this means for part B is that because we know that A is acute, right? So we can literally draw a right angle triangle with an acute angle alpha. And we say tangent of alpha, remember tua ka so, in America they call it tokasoa. But anyways, we call it tuakaso, like topayo, tua. What does tua mean? Is tangent is equal to opposite over adjacent, right? So in a right angled triangle, opposite to the alpha means this length over here. You should know this already from Emacs. Opposite is, okay, you have square root 2 over 2, which means it's opposite over over adjacent. Opposite over the adjacent. So the opposite length is this length here, which is your numerator lor, which is square root 2. Then how about your adjacent? Adjacent is just this guy over here, which is length 2. How about the hypotenuse? Hypotenuse is just very simple, 2 square plus square root 2 square, whole thing take the square root. What does that give you? Whole thing take the square root of a 4 plus a 2, which is square root of a 6. Right? That's just Pythagoras theorem. Sum of the square of the shorter sides. Then you take the square root. Okay, so square root of 6 is the length of the hypotenuse. Very good. Then that means we can find every single ratio that's related to alpha already. Sine of alpha, cosine of alpha, tangent of alpha. Just use Tuakaso. It's like E-math already. Now in this case, the part B is actually sine of 2 alpha. Sine of 2 alpha. Which is not just sine alpha, it's not cosine alpha, it's actually 2 sine alpha cos alpha. Break down the 2 alpha into a 1 alpha. But wait, now that we know this right angled triangle, can we find out what sine alpha? Yes, opposite over hypotenuse. 2 times opposite root 2 over the hypotenuse root 6. Multiplied by cosine alpha, adjacent over hypotenuse. Adjacent is a 2, hypotenuse is a root 6. So we multiply out everything 2 root 2 times 2. Root 6 times root 6. Okay? 2 times 2 times root 2 is 4 root 2. Root 6 times root 6 is a 6. 4 over 6, 2 over 3, root 2. Then we are done for part B. Let's take a look at part C, cosine of 4 alpha. Now in this case, cosine of 4 alpha, you can see that actually it's just the double of a double. Right? Because 4 is really 2 times 2, right? 4 is 2 times 2. So it's double times 1. It's like a double one time and then you double a second time. It's like using double angle twice. Right? Let's take a look. Now, cosine of 4 alpha. In this case, I would say that since we have already found out what is sine of 2 alpha, it would be better to make use of there's 3 identities that you can use regarding the double angle formula for cosine. I would suggest to you to use the one which involves more sine squares. Okay, cosine square, the first guy is cosine square minus sine square, which has some sine square, but we can do better. There's another one which is 1 minus 2 sine square. Wow, purely in terms of sine square and constants, very good. That seems very desirable. How about 2 cos square minus 1? Oh, this one definitely not. That's cosine square. That's not what we already found. We only managed to find sine 2 alpha, but we managed to find sine 2 alpha, which is something in terms of sine, not cosine. So this third form we don't want. In fact, this cosine square A we also don't want. We just want the this form, 1 minus 2 sine square. That's the relevant one. Let's just work it out. How do we use it? Now in this case, 4 alpha is acting as the 2A. Okay, it's acting as the double angle. Just remember, this side is the double or the bigger one. Then this side is the single A, is the smaller or the half or smaller. Okay, let's just write it out neatly. Half of the small. So what this means is every time you see cosine on its own, then you try to use the identity. Make sure that whatever you end up over here has smaller angle. Smaller by how much? Smaller by half. Just times half. So 2 copies is 4 alpha. So if you want 1 copy, half of 4 alpha, what would that be? It will simply be 2 alpha, right? So every angle inside here will be something 2 alpha. Okay? Can? So now let's try and figure out what is that. We use this identity, 1 minus 2 sine square. 1 minus 2 sine square of A. In this case, A is half of 2A. How do you get half of 4 alpha? It's really just 2 alpha. 2 alpha. Okay, so now I remove all the extra bells and whistles. It's really just 1 minus 2 sine square of 2 alpha. If you can see it directly, good. I hope my elaboration was enough. If you're not so sure, let me know if you're still not sure. So sine square of 2 alpha is really just sine of 2 alpha, then you square it. We already found out what sine of 2 alpha. It's this guy, which is 2 over 3 root 2. But then you have to square it. So bracket square. Okay, lor, continue. What do you get? 1 minus 2 times 2 square, 3 square, square root 2 square. Oh? So what do you get? You get 1 minus 2 times 4 over 9 times square root 2 square is 2. Okay, great. Continue expanding. 1 minus 2 times 4 times 2. 2 times 4 is 8. 8 times 2 is 16. 16 over 9. 1 minus 16 over 9. That means that you're left with 7 over 9. And finally, that's cosine 4 alpha, and we are done.